Let's build a computer! Recently, I came into possession of an 8-bit breadboard computer set, which shows you how to make a computer using these. But first, what is a computer? Now, computers come in all different shapes and sizes, but everything from a fighter jet to a smart fridge has these 5 things in common. It has something which can take in input, something which can give away output, some sort of memory module which can store data, and then 2 components over here which are sometimes called the processor. You've got the control unit and the data path, which is responsible for doing all of the calculations and logical operations that you'll see in a normal instruction. Also, these components need to share data a lot. To do this, they put their data on what's called a bus. Now, the boss of this computer here is the control unit. Millions of times a second, in order for your computer to do anything, the control unit reads instructions from memory, figures out what they mean, and then tells the other components what to do in order to achieve that goal. If you've ever taken a computer science class before, you may have heard this be called the fetch, decode, execute cycle. Now, just because the control unit's the boss of the computer, doesn't make it the most important part of the circuit. In fact, I'd say the most important part is clock. Now, to explain the clock, let's imagine a situation here. Imagine we're looking at this part of the computer. Our data path is performing some calculation, and then the result is going to be copied across the bus into memory. However, let's say our input changes. How do we make sure that the memory doesn't copy too soon? That's where the clock comes in. It's slightly slower than all the other components. When it sends out a signal, as it does at a consistent rate, all components can be confident that calculations have been done. And so, the memory can copy the data safely. Thank you! It works! Now, before we go any further, let's hold our horses, because there's actually 3 types of clocks that we need to know about here. The first one is an astable clock. These clocks have no stable state, so they flick between 1 and 0 on repeat. The second type is called a monostable clock. These clocks have a stable state, so you have to induce something into them in order to change it. For example, pressing a button might turn the light on for a set period of time, and then it'll go back to off. And the third one's kind of useless, but I thought I'd talk about it anyway. It's called a bistable clock, and it's basically the same thing as a switch. You flick the clock one way and the light stays on, you flick the clock the other way and the light stays off. You use it for something called debouncing, which is a very fancy electronic engineering term for making sure something doesn't flicker on and off when you press a button or something. Okay everyone, I think I've set this up correctly so that when I plug this in, nothing happens. But when I press this button, I should get a little pulse out of this. Wait, this wire here should be into ground, but why? Hey, it worked. Woo! Let's go. Let's go.